This is a podcast of Scripps Institution of Oceanography at UC San Diego. To learn more about how you can support Scripps, visit us online at scripps.ucsd.edu. One of the greatest discoveries of modern medicine was Alexander Fleming's 1929 discovery of penicillin from a fungus in soil. For the next 50 years, medicine hunters looked high and low across terrestrial environments for similar natural microbes from land that could be used to treat illnesses. More than 120 antibiotics were developed in the decades that followed Fleming's discovery. But in time, bacteria emerged that proved resistant to penicillin and other drugs. Today, most pharmaceutical companies have abandoned the search for new terrestrial sources altogether. William Fennicle of Scripps Institution of Oceanography at UC San Diego believes new solutions could come from the seas. Because the oceans cover more than 70% of the planet and are home to the broadest diversity of life on Earth, Fennicle believes treatments to fight infections and diseases such as cancer will come from the ocean and its broad, largely unexplored geographical breadth.
I think one of the most critical needs for pharmaceutical products today turns out to be antibiotics because of our recent recognition that drug-resistant pathogens, human infectious diseases, are causing havoc, and that we have a problem. We can't treat these diseases. They, in fact, are the single most important medical emergency we have in front of us. But now what we have remaining in terms of antibiotic discovery, and many other drugs as well, is the vast microbial resources that are found in the world's oceans.
Terrestrial microbes have been looked at for 40 to 50 years, and they're basically tapped out. In other words, you're seeing the same structures over and over again, the same chemicals over and over again being extruded by the microbes from terrestrial sources. So the ocean has never been exploited before. And Nereus, through our association with UCSD, is in my opinion and my knowledge, the only company in the world today that's 100% dedicated to drug discovery from ocean microbes, because they're unique, different, never been seen before.
Given the immensity of microbes in the sea, somewhere around 10 to the 6th cells per milliliter of seawater, somewhere around 10 to the 9th cells per cubic centimeter of the bottom sediments, that this is a resource that could be examined for 100 years, leading to a fresh new group, a new components of antibiotics or anti-cancer drugs, and that's our goal right now.
William Fennicle helped launch the field of marine biomedicine more than 37 years ago. In 1998, he founded the Scripps Center for Marine Biotechnology and Biomedicine, a thriving research cluster that continues today with students, postdoctoral researchers, and other scientists.
Nowhere in the world is there a first-class oceanographic institution adjacent to a very, very high-quality medical school, and nowhere are those boundaries broken as well as here at UCSD. So we have tremendous interactions with our colleagues on the main UCSD campus in, as I said, pharmacy and medicine and biology, and we are developing more collaborations every single day. We have worked more extensively with cancer over the past 15 years than with antibiotic discovery, and have 2 molecules from the marine environment currently in phase 2 clinical trials for different forms of cancer. But more recently, our work with antibiotic discovery has led to at least 6 different structure classes, so far unknown from any other source, that have the ability to completely inhibit the growth of MRSA, methicillin-resistant Staph aureus. And so this progress in the matter of only about 2 years of screening and collaboration with our medical school colleagues has already yielded an enormous amount of information that could lead to these as drugs.
You know, there are a lot of challenges to this type of work, and part of that just relates to, you know, the ocean's pretty deep, and we're very interested in accessing those deep samples, and it's not trivial to do that, especially at the scale that we need. We don't need a major oceanographic research vessel to go out and collect the small quantities of samples that we need to isolate bacteria from. And so we've spent a lot of time trying to miniaturize collecting devices and be able to use them off of small boats that aren't as expensive. And so we can go to a remote location, hire a small fishing boat, and go offshore and be able to access deep ocean sediments there.
What we've learned in the past 30 years is just how unique life in the sea is. We now know that organisms are exquisitely adapted to live in a high salt environment. Often organisms are adapted to live under high pressure in the deeper parts of the ocean. Wonderfully, we see this unique, separate evolution of life in the sea and the opportunity, therefore, to explore and develop new products from marine microbes.
There's a lot of satisfaction knowing that ultimately the research that we're doing may lead to a cure for some chronic diseases that everyone's aware that there's a real need for new medicines. And so you know, on a daily basis we don't think about that because we have our noses to the grindstones, but at the end of the day, you know, we always hope that one of the molecules that we discover will actually become a useful drug.
This has been a presentation of Scripps Institution of Oceanography at UC San Diego.